Hi, I'm Professor Kelly, and this is a lecture on polymorphism for CS-CI 308, Programming Language Design. You've probably heard the word polymorph before, perhaps in fantasy literature. Polymorph is used, for example, in Dungeons & Dragons to describe when a werewolf turns into a wolf, or when a doppelganger transforms into some person they've seen. In computer science, polymorphism is a feature of a programming language that allows routines, functions, or data structures to use variables of different types at different times. Polymorphism is particularly characteristic of object-oriented programming, but it can also be found in other types of programming language. Polymorphism comes from the Greek, meaning many forms. The learning goals for this lecture are, by the end of it, you should be able to identify examples of polymorphism in languages, distinguish between overloading, inclusive polymorphism, and parametric polymorphism, and determine when overloading is allowed in a language. Kinds of polymorphism include ad hoc polymorphism, also known as overloading, which is when functions can take different forms, or operators can take different forms. Inclusive polymorphism, which is when data types can take different forms, and parametric polymorphism, which is when parameters can take different forms. With ad hoc polymorphism, or overloading, multiple functions or operators can have the same name. Overloaded functions are distinguished either by their scope or by their parameters. And that's an inclusive OR. An example of overloading in Python is the plus sign. 3 plus 4 is 7. However, if we take 3 plus 4 in quotation marks, we get 34 in quotation marks. Or if we take a list consisting of 3 and a list consisting of 4, we get the list 3 and 4. Overloading is allowed in different circumstances in different languages. Most languages allow overloading or functions with the same name when the functions exist in different scopes, such as when the functions exist in different classes. It's also quite common to allow overloading when a child function overrides a function it inherits from the parent. Overloading can also occur when a function has different parameters but the same return type. This is allowed in Java, but is not allowed in C, C++, or Python. Different programming languages allow overloading in different circumstances. For your project language, experiment to find out when it allows overloading to occur. Some programming languages allow operators to be overloaded. By operators, I mean symbols, usually infix symbols, that can be placed around variables, such as plus, minus, divide, multiply, equals, less than, greater than, not equals, modulo, and so on. Java does not allow you to override operators. Conversely, Python lets you overload the operators that it inherits from the class object. All objects in Python inherit from the class object, and they inherit functions such as add. Here we've created a class called cloud, which defines an add function where we add the saturation of one cloud to the saturation of another cloud, and the width of one cloud to the width of another cloud. Given a cloud X and a cloud Y, we can sum them together to create a cloud Z, which will have saturations and width that is the sum of the two clouds' individual saturations and widths. C++ and Haskell also let you override existing operators. This is an example from Haskell. Pair AB allows us to add, multiply, subtract, and other functions. Here we are adding pair 4, 5 and pair 6, 7 to get pair 10, 12. and multiplying pair 4, 5 and pair 6, 7 to get pair 24 and 35. Haskell also allows you to create new operators. In fact, in Haskell, it's generally preferred to create a new operator instead of overloading an existing one. Here, we are once again using the pair data structure that we've created last time, but this time we've created a new operator for it, a plus sign with 2 bars next to it. This also now allows us to add pairs together, and does so without overriding the existing plus operator. Inclusion polymorphism is when a data type can refer to a set of different types. The union formal type is an example of inclusion polymorphism, such as pet equals dog or cat, meaning that a pet could either be or a dog or a cat. Another example is when a variable can hold values of its subtypes or of its children. For example, if you had a parent class A and a child class B that inherits from A, and you created an array of A, it would be an example of inclusion polymorphism if the array of A's can include a B. Parametric polymorphism is when a function or type operates the same no matter what types of input is given. This can be implemented either using optional parameters or generic parameters. With optional parameters, these are parameters that could, say, have default values, like in Python, or be a variadic function that can take any number of parameters, such as the printfs function in C or the print statement in Python. All bash programs or functions are such that they can take any number of parameters. Generic parameters are another way of implementing parametric polymorphism. A generic parameter is when a parameter is non-specific to a particular type. For example, we can create a function getSecond in Python that will work for anything that can be indexed, such as a list, dictionary, or string. C has the sizeOf function, which can take many different types as its parameters. In Haskell, we can define a greater function that will work for anything that's ordinal. To explain the syntax here, we're defining a function greater and saying it takes a type that is ordinal. And in fact, it takes two things that are ordinal of the same type and returns something of the same type. And then we define inside of that function greater xy equals if x greater than y, then x, else y. In other words, if x is greater than y, return x, otherwise return y. To sum up, ad hoc polymorphism, also known as overloading, allows functions or operators to take different forms by having multiple definitions for the function or operator. Inclusive polymorphism allows data types to take different forms, and this can be implemented in a number of ways, such as a subtype or child class being treated as the same as the parent type or class. Parametric polymorphism, which is when parameters can take different forms, which can be implemented either as optional parameters or generic parameters that are non-specific to a particular type. Overloading functions or operators that are overloaded can be distinguished by scope and/or by parameters. The specific situations where overloading is allowed varies from language to language.